Hello everyone, this is Ayush. This is the presentation for our capstone project, Image Search Engine, Query Dependent Image Re-ranking using Click Data and AutoEncoders. This project was created by myself, Ayush Gupta, Akshay Patni, Arush Gupta and Arti under the guidance of our mentor, Ms. Harkiran Kaur. So the objective of our project is to improve the performance of query keyword-based image search engines by re-ranking their baseline results. That are the results that we get just using the tags. So we've taken a hypothesis that images clicked in response to a query are mostly relevant to the query, and we aim to re-rank the original search results so as to promote images that are more likely to be clicked to the top of the returned list. So the tools that we've used are JavaScript, Angular, and Bootstrap for creating the front end of the website. And for creating the backend API, we've used Node.js and Express.js along with MySQL to store the data and NLTK for query processing and stemming and other natural language things that we're doing. Apart from that, we've also created an autoencoder, and we've done that using Python and TensorFlow. So basically how our algorithm works is the user search for their query and click on an image. This click is recorded and a list of images is retrieved using their textual tags. The retrieved list is then sorted based on the tags, based on a tag weight. So we have already assigned tag weights to the images. Apart from this, they are also sorted based on similarity to top 5 clicked images for that query. And how we're sorting these are we're using the encoded image vector. So the autoencoder that we're using encodes the images into 30 into a vector of size 32, and we're taking the cosine distance of the images to these top 5 clicked images, and also predicting and using this information we are predicting how many clicks will those images get, and finally combining the real clicks and the predicted clicks we are returning the list of the images back to the users. And the offline algorithm, so that the autoencoder, it basically runs after a fixed amount of clicks. So for now we've set 1,000 clicks. So for any query, when we get 1,000 clicks for that query, the autoencoder is run for that tag, for that query, for all the images. So like if we are retrieving 100 images based on a particular query, then all of those 100 images are fed to the autoencoder, and they're encoded, and the encoded output is recorded in our database. So running the autoencoder again and again on the images just improves the encoding quality so that we get better results every time a new iteration is run. So now let's have a look at the project. So we are basically using this paper by Manik Verma, Learning to Re-rank Query Dependent Image Re-ranking using Click Data. We've also added in autoencoders. We've additionally provided a new thing, that is autoencoders. So here's the image search. So the dataset that we have taken has images of all these categories. So I'll just show what kind of query could get better results using our techniques. So if we search for a baseball bat, so here as you can see the top image, one of the top images that we are getting, that is the baseball glove and ball, and a bat is like sidelined. So and images like these and images like one on the right and the one below it are quite down. So once a user searches for a baseball bat, most probably he'd click on an image something like this. or this. So if we click on this image and have a look at the database, so we have recorded a click for that query. So now using the autoencoder, after 1,000 clicks, we'll finally get uh, a vector. So I'll just show you the vector, how it looks. So till the notebook is starting, let's just have a look at the API first. So uh, yeah, we've created the API for search. So it gets the query, it splits it into tags, and then finally uses that to create a query for the database and gets the images from the database, and then ranks it according to the thing I just showed you. So like the process I just showed you. And other than that, we have the re-rank API call. So this is nothing but just adding the click to the database for the given query string. Yeah, so the API is pretty much this simple only. And other than that, we are also using a dictionary called the WordNet dictionary to get alternate words for a given word. So like if you are searching for aeroplane, plane, airplane, and other words that are almost similar in meaning with aeroplane should also be searched. Okay, other than this, we have, okay, so okay, nothing, yeah, so we have the notebook here in which I'll show you the autoencoder that we're using. So yes, this is the autoencoder that we are using in our project. So basically it takes the images from our data set and create and downsizes it to 100 by 100 image, and since it's colored, so it's 100 by 100 by 3, the dimensions of the image. After getting that, it just normalizes the image and adds it to memory. So here's a sample image, so like how it looks. So these are zebras here. So for processing this, then we have a function for getting the batch. So finally we have our neural network, so the autoencoder that we're using. So it has a learning rate of 0.01 and 5,000 steps, so like the iterations, and a batch size of 32. So like 32 images are processed continuously. And then the network that we have is a 7-layered network, sorry. So the first layer is, it's a 7-layered network. So the first layer is the input layer, so its size would be 100 by 100 by 3, so that's 30,000. The second layer has, so like this is the first hidden layer, it has 512 nodes. The next layer, it has 128 nodes, and the last layer of the encoder has 32. After that, we have the decoder layers. So it also starts with 32, 128, and 512. Then we're using both of these and using the Adam optimizer to optimize the learning, and we're using the loss function as the reduce mean loss function, and then finally we are running this. So here, as you can see, we've continuously decreased the batch loss. So it's 0.07% after these images are trained. So this is how an image would look like after it has been encoded, and this is what we'll be using to find distance between images. And yeah, that's pretty much it. So how it works. So thank you for watching.